Okay, sorry. Got interrupted, and going to have to do this lesson in two parts. We'll just pick up where we left off. We're talking about this special relation, which we call a function, and all it says is that each input should only get mapped to one number in the output, and that would make it a function. If it's not a function, then one of your numbers or more than one of your numbers in the input is going to go to two or more numbers in the output, and that would make it not a function. Real quick, let me show you the ordered pair of this. One is getting mapped to 2, so there's an ordered pair of 1, 2. And 2 is getting mapped to 3, and 2 is also getting mapped to 4, and 3 is getting mapped to 2. So if we were to show, or if you were to be given a set of ordered pairs and it asked you, hey, is this a function or not? What you want to check for is to make sure that each input value is just going to one output. So here, 1 gets mapped to 2, and then I don't see another input value of 1, so that's okay. But notice that 2 as an input value in this ordered pair gets mapped to 3, and in this ordered pair gets mapped to 4. So this is violating our rule for functions by having an input value that has more than one output value. Okay. And then, of course, the last one, 3, 2, that's fine. That's not breaking any rules. But right here, we've got two ordered pairs where the input value 2 is getting mapped to different output values. So that violates our rule for functions, and you say, not a function. Okay, so let's talk a little bit more about input and output, because I'm going to put new terms in here. Input means domain, okay, and output means range. These are interchangeable names. Input, domain, output, range. I'm giving you the definition. If somebody said, hey, what's the domain of the function? They're just asking, what are the input values? And if somebody said, what's the range of the function or relation? They're just asking you, what are the output values? So, for example, let's go back up here and talk about range and domain. In our relation that we were putting in here in this mapping diagram, what is the domain? Well, the input values are 0 and 1. So our domain are the numbers 0 and 1. And we could write that just in list form. You say 0 and 1. Okay, remember set notation. There's our domain is 0 and 1 here. And if it said, what is the range for this? And it's got our mapping diagram again. Our output values are 1 and 3. So our range are the numbers 1 and 3. Okay? Input is your domain, your output is your range. It's just that simple. So let me go to some examples in your book. Problem number 1 here says, identify the domain and the range for each relation. Okay? So remember, the domain are the input values. So here it's giving us the ordered pairs that make up that relation, right? And if I was trying to find out what the domain is, the domain here is going to be -2, because remember the first number of the ordered pair is your input. So -2, 0, 4, and 5 are your domain. -2, 0, 4, and 5, because those are the input values in your ordered pairs, okay? The domain. And then the range are going to be the y values, or the output values in each ordered pair. So the first number in the range is 0.5, the second number is 2.5, the next number 6.5, and the last number 2.5. Now notice that since 2.5 occurred twice, I don't have to list it twice. I mean, once I've listed the number, it's there, I don't have to count the same number twice. So when we list the range, the y values, the outputs, they're going to be 0.5, 2.5, and 6.5. I didn't have to list 2.5 again because I already listed it once. All right, so there it is. Now, let's do the same thing over here. What's our domain? Well, our domain are the numbers 6, 4, 6, and 5. Again, I don't have to list 6 twice. So my domain is just 4, 5, and 6. Right? Those are the first numbers in the ordered pairs. The range, the second numbers in our ordered pairs, the Y values, our outputs are 5, 3, 4, and 8. Not necessarily in that order, but 5, 3, 4, and 8. Okay? Again, domain is just saying, hey, list the numbers that are input values, and range is list the numbers that are output values. Okay? All right. Let's move on to this one, and it says, hey, you know what? There's this cool test for when you have a graph of a relation or a function to tell whether or not it's a function. And it's called the vertical line test. The vertical line test says that if I can draw any vertical line that passes through more than one point on the graph, it wouldn't be a function. And the reason it wouldn't is that our x-axis represents our x values, and our y-axis represents the y values that can occur. So if I'm looking at this, notice that like for an x value down here, there's a corresponding y value that's right here. That is to say that if each of these are worth 1, -1, -2, -3, -4, 2 is the coordinate for that, right? -4, 2. But notice on the graph that if I go to -4, there's also a point at -4, -1. So this is violating our function rule. The same input value, -4, is being mapped to two different output values, 2 and -1. So again, it's not a function because our input value is getting mapped to more than one output value. Our input value of -4 is being mapped to two different output values. And to be a function, each input can only have one output. So graphically, what that means is that if I draw a line through here, I'm going to hit more than one point, right? If I draw this vertical line that goes straight up and down, I'm going to end up hitting both of these points wherever it violates the rule to becoming a function, right? So for this point, nope, that's fine. It's not hitting any other point. Where this one is, no, it's good. It's not hitting any other point. Here's a point here. Draw a straight line through there, up and down. It's not violating our rule. But here, because it hit 2 points on that one vertical line, I know that graphically it's not passing the vertical line test. So this is not a function because there's a vertical line that crosses two different points. And if it was a function, that would never happen. Okay, let's check this one. Anywhere I can draw a vertical line, will it cross, in the graph here is this red parabola, right? Is there any way I can draw a vertical line where it will cross through 2 points on that parabola? Nope. No matter where I choose to draw a vertical line, it's always only going to cross through one. Therefore, something that looks like this is a function. So we can tell using the vertical line test that this is a function and this is not a function because this one fails the vertical line test. This one passes the vertical line test. It doesn't cross through more than 1 point of the graph. Okay? Okay. Now, function. Function notation is when you write things like f of x. Now, notation-wise, we've been writing lines like y is equal to 3x plus 1. That's in mx plus b form. We're pretty comfortable with that. But in function notation, I can write the same thing as f of x is equal to 3x plus 1. it's kind of like saying, it's kind of like saying y is equal to 3x plus 1. But this is just saying that the function with an input value of x is 3x plus 1. It's kind of what we were doing before. I mean, y was our output value, x was our input value. So this is a function, and we could say the function that gives us an output of y is equal to 3x plus 1. This one says, the function with an input value of x, right, is going to be 3x plus 1. So f of x is now just taking the place of our output variable. Why would we do such a thing? Well, suppose that we were talking about a different function. Y is equal to negative 2x minus 7. That's a different function, isn't it? But how would I know if I was talking about this y or this y? Because they're not the same, are they? If I name my functions all the time by just using y equals blah, 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 right? Y equals blah, blah, blah. How can I talk to you about more than one of them? The answer is I could use function notation. I could name this function g of x. All right? Now, I can then tell you, okay, for f of x, see what you get when x is equal to 0. And you could go, you get 1. Because I'm talking about this function plugging in 0. And in fact, I can do that by saying, I wonder what f of 0 is. So I can not only distinguish which one of these I'm talking about, is it the one on the left or the one on the right, but I can also at the same time tell you what number to plug in for x. Here it says plug in 0 for your x. And that really means that what you're going to do is that's 3 times 0. You're replacing x with 0 plus 1. So that f of 0 is equal to 1, because 3 times 0 is 0, plus 1 is going to give you 1. Okay? I wonder what happens when you do g of 0, or when you plug in 0 for your input on function g. Again, you can say, that's like saying g of 0, isn't it? Which is going to be like negative 2 times 0 minus 7. So function notation allows us to determine which function I'm talking about, and at the same time allows me to tell you what input values you're going to use. G of 0 is equal to negative 7. Okay? So function notation allows us to do two things: to name the functions, and also then it gives us a place to put numbers in for our variable x. All right? All right. Let's go back to examples from the book. This one here says, finding the range of a function. The domain of f of x is equal to negative 1.5x plus 4 is, and it lists the numbers for the range, or for the domain. Now, remember what domain means. Domain means these are the numbers that we're going to plug in to the input value. Well, what would we get if we used these numbers and plugged them in? So here's a table, right? They're plugging these numbers, 1, 2, 3, and 4, in for x. So they've put a little column for x, and we're going to plug in 1, 2, 3, and 4, because it told us this is the domain. It's asking what the range is. So what that means is, what are the output values when you plug these input values in? Okay? So remember, f of x is taking the place of y. So in your brain, if it helps you to think in a table form that these are your y values or your output values, this is what you're going to get. Now, in the middle of their table, they're actually plugging those values in to the function. They're taking negative 1.5, multiplying it times their x value, and adding 4. So this is the actual function they're using. they're just plugging in your X values, your inputs here, to show you that when you do the math here, you get this output value. So they're saying when you plug 1 into the function that it told you, you get 2.5. When you plug 2 in to the function they gave us, you get 1 for an output. When you plug in 3 for an output, you get negative 0.5. And when you plug in 4, you get negative 2. So these numbers then become our outputs. Therefore, the range are these values. Negative 2, negative 0.5, 1, and 2.5. That's where the range numbers came from, right? So that's what you do with those. You're just going to give these numbers, plug it. You're going to get these numbers because it says that's your domain. You're going to plug these numbers in 2x, use a table to find out what your range is, what your output values are, and then you just list those. Okay, that's what you do there. Finally, the last thing that we have to talk about. Woo! They're all like, phew, this is too long a video, Mr. Fokin. Get to the end, get to the point. All right, this is the last thing. It says, let's identify a reasonable domain and range. And what that means is that the difference between the abstract algebra piece and the real world application of the algebra. So we might have a function like up here. They had a function that was negative 1.5x plus 4, right? And we can plug any number we want in there. But in the real world, maybe it doesn't make sense to plug in certain values. So let's read this. It says you have 3 quarts of paint to trim your house. A quart of paint covers 100 square feet. The function a of q is equal to 100q, represents the area a of q in square feet that q quarts of paint will cover. What domain and range are reasonable for the function? All right, so we have 3 quarts of paint that we can use, right? Q at most can be 3. Why? Because it says I have 3 quarts of paint. I can't plug 5 in because I don't have 5 quarts. I have 3. So it's not going to make sense to say like 100 for my Q, is it? Because I don't have 100 quarts. I have 3. Now let's go to the other side. Would it make sense to plug in negative values for your Q? No, because I don't know I don't even want to guess what it means to have negative quarts of paint. I can't have negative quarts of paint. I could have 0. I maybe am lazy and I don't want to open a can, so I have 0 quarts. But we have 3. So what makes sense here is to say that the number of quarts I have to plug into my function are going to be between 0, where I don't even use 1, and 3, because that's the most I have, okay? So if I don't paint, I don't use any quarts at all. But if I do paint, I at least have to open up a can or 2 or 3, but I can't open up more than 3 because that's all I have. All right, unless I go back to the store, which changes the problem. But I have 3 quarts, so my domain is going to be between 0 and 3. So here's how we can write that. 0 is less than or equal to the number of the quarts I have, which is less than or equal to 3 because 3 is the most I can use. Now, if that's the case, I'm going to do just like we did before. I can make a table. The possible input values are 0, 1, 2, or 3, right? And I was told before that the function is 100 times the number of quarts. Okay, so to find my output values, I'm just going to multiply my input values by 100. So 0 times 100 gives me 0. 1 times 100 gives me 100. 2 times 100 gives me 200. 3 times 100 gives me 300. Therefore, my output values, or my range, goes from 0 to 300, okay? 0 is a minimum and 300 is a maximum, and I could write that over here as 0 is less than or equal to A of Q, which is less than or equal to 300. All right? Make sense? So we can talk about our domain. What can we plug in? Anything from 0 to 3, because I only have 3 quarts of paint. And when I plug those in, I get output values that go between 0 and 300 based on that A of Q, that function that they told me about before. So my function value, A of Q, lives between 0 and 300. Groovy? Groovy. All right. Use that knowledge that I've just imparted to you, hopefully, to work on your homework problems. Good luck with them. Have a great day, and hopefully we'll be talking to you in person soon. Bye-bye.